fx equal to 3x cubed minus 3x plus 3. So f prime is 3x squared minus 3. Yeah. So that is equal to 0. That is equal to 0. So we have x equal to plus 1 or minus 1. Yeah. Plus 1 or minus 1. So here f prime actually is this prime. Yeah. So this prime is 6x. 6x. So f prime 1 equal to 6. Yeah? Equal to 6. F prime 1 equal to 0. F prime 1 equal to 6. Greater than 0. So here actually this one is the relative minimum. Yeah? And f prime minus 1 is equal to minus 6. So here is the relative maximum, yeah, maximum. And now here is plus 1 minus 1. So minus 1 here, plus 1 here. So we have three. We have three intervals. The first interval is minus infinity to minus 1. The second interval is minus 1 to 1. The third interval is 1 to plus infinity. So minus 1 to 1 here, this part, we can see the f prime actually is greater than 0, yeah? Greater than 0. So here actually is greater than 0. This part is less than 0. Here is greater than 0. So here actually is increasing, decreasing, and then increasing. So minus 1 is a relative maximum. 1 is a relative minimum, okay? So I think that this is the end of this section, okay? So this section, we introduce the critical points. The critical points, so the critical points and the first deductive test, the second deductive test, okay? So this is the end of this section, 5.2, okay, 5.2. So now we see the page 200 and 225. Okay, 225. The last section actually is sketching. Okay, we omit it. We do not have. Okay, we do not have so much time. So I want to introduce the old book this semester. So I do not have so much time. So here this section. 5.3, we omit it. We go to 5.4, okay? 5.4, the absolute minimum and maximum, okay? So here we go to the 5.4, okay? 5.4. Okay, 5.4 here. Here, this part, okay, this part is the absolute minimum or maximum, okay? The absolute minimum or maximum. So first we see a graph. Okay, we see a graph. For this graph here, in this interval here is 0, here is 1, here is 1. So here like this. Okay. Okay, now let's see, this is a graph of a function, So here we can see this point, for example, here is x1, and this point is x2, here is x3, and here is x4, here is x5, here is x6. Now we can see here this point, okay? This point actually is a relative maximum, yeah? A relative maximum. And this point is also a relative maximum. This point is also a relative maximum, okay? So here, this one, okay? The first here, the third point, okay? Or the 3 points. The first one, the second one, the third one, okay? The 3 points actually is a relative maximum. But around this 3 points, which is the largest value, this one is the largest value, yeah? This one is the largest value, means what? Means in this point, okay? In this point, fx3 is the largest value on the interval 0 to 1, okay? On the interval 0 to 1. fx3, we can see fx3 is the largest value on 0 to 1, okay? On 0 to 1. So this interval, okay? So here means the largest means what? The largest means what? The largest actually means fx3 is greater than or less than or greater than or equal to fx for any x. For all x belongs to 0 to 1, okay? fx3 greater than or equal to fx for all x belongs to 0 to 1, okay? So here this means the largest value, okay? The largest value. Now we can see at this point, at x to this point a relative minimum. Here is also a minimum. Here is also a minimum. So we have 3 relative minimum. Okay? The first one, the second one, and the third one. So at this, okay. So around these three minimum, who is the smallest? The smallest value actually is here, yeah. Actually is here. So here means that fx6 is the smallest value on 0 to 1 on this interval, okay, on this interval. So fx6 is the smallest value on this interval. So here means what? The smallest, okay, the smallest means what? Means actually fx6 we are less than or equal to fx for all x belongs to 0 to 1, okay? For all x belongs to 0 to 1. So here fx6 is the smallest value on 0 to 1. So here means fx6 less than or equal to fx for all x belongs to the 0, 1. So here means what? Here means actually, so fx3 called the what? fx3 called the absolute. So x3 means the maximum, okay? Maximum. And x6 means the absolute minimum. So x6 is the absolute minimum, x3 is the absolute maximum. So here we need to give a definition of the minimum, absolute minimum, and absolute maximum. Okay. So I'm sorry, you need to turn this on. Okay, turn. So now let's see the definition. Now let's see the definition. Okay, consider an interval pair of a function f and a point x0 in that interval. We say that f has an absolute. We say that f has an absolute maximum at x0 if fx less than or equal to fx0 for all x in that interval. Okay, so here this one is the definition. Okay, this one is the definition. Here fx less than or equal to fx0 for all x in that interval. Okay, in that interval, this is the definition. Okay, this is the definition of absolute maximum. Okay. So here the second, we say that f has an absolute minimum at x0 if fx0 less than or equal to fx for all x in that interval. Okay, in that interval. So here this one is the definition, the key point of the definition of absolute minimum. Okay. So we say that f has an absolute extreme at x0 if it has either or absolute maximum or absolute minimum at that point. Okay, at that point. So here this is the definition. Okay, so this is the definition. Now, so this is the definition of the maximum, absolute maximum or minimum on an interval. So the interval, so now we can see the interval. Okay, we can see the interval. The interval actually can be a closed interval or open interval or infinity interval. Okay, or infinity interval. So here, now, so the interval can be a closed interval A B or an open interval AB or infinity interval minus infinity to plus infinity. Okay. So the interval can be closed interval, open interval, or infinity interval. Okay. So for these three cases, we discuss the absolute value, absolute extrema. Okay. So for these three cases, we discuss the absolute extrema. So the first one, now let's see the case one. Okay, the case one where I is a closed interval. Now let's see I. The first one. Okay, the case one when I is a closed interval. So here, now we give three examples. Okay, we give three examples. The first example is fx equal to x for this function. Okay, for this function in this interval in 0 to 1 in this interval. Okay, in this interval, we see this function. Okay, we see this function. So we plot it. Okay, we plot it. Here is x, here is y, here is the origin. So here is 1, here is 1. So we plot the graph. Actually like this. So here, this is the graph. This is the graph, okay? So from here, we can see the function fx equal to x for this function in this interval. What is the absolute value, or what is the absolute minimum, and what is the absolute maximum? So in this interval, we can see this point, because here is closed, okay?
Yeah.
The left is closed, the right is closed. So here, this point actually is the absolute minimum, yeah? And this point is the absolute maximum, yeah? So here for this function, okay? So for this function fx equal to x, okay? So for this function, it has absolute minimum, okay? It has absolute minimum at what? At x at 0 this point. And this function it has absolute maximum, okay? Maximum at 1, okay? At 1. So here now we can see the absolute minimum or maximum takes at the end points of the interval, yeah? At the end points, okay? At the end points. So here means, okay, for this function, the absolute minimum and the absolute maximum takes at the end points of the interval. So this is the first thing. So the first example. For the second, okay. For the second here, now let's see the function fx equal to sin x. For this function in this interval 0 to 2 pi, in this closed interval, okay. In this closed interval, so here we plot the graph.
fx is equal to sin x.
Here is x, here is y, here is the origin, so here is the negative.
0 x y.
So here is 2 pi, here is pi. So here, now in this interval, okay, so here we can see the maximum actually is here. Yeah, so the absolute maximum is here actually is 1/2 pi, and the minimum actually is here is 3 pi by 2, yeah, 3 pi by 2. So here for here, so we can see that the function fx equal to sin x, okay, equal to sin x. This function has absolute maximum. It has the absolute maximum at the point 1/2 pi, okay, 1/2 pi. And it has absolute minimum, okay, minimum at 3 pi by 2, okay, at 3 pi by 2. So here now we can see 1/2 pi and 3 pi by 2. These 2 points is not the end points of the interval. These 2 points actually is what? Is the critical points of the function, yeah? Actually, these 2 points, actually we computed it, is actually is the stationary points, yeah? Yes. Actually, you can, it's easy to find. F prime 1/2 pi equal to 0, F prime 3 pi by 2 equal to 0. So these 2 points actually is the stationary point of this function. It's also the critical points, yeah? So here means the absolute maximum and the absolute minimum. Okay, it takes not at the endpoints, but at the what? At the critical points. Okay, critical points. Critical points. So this is the second example. Now for the third example, for this example. For the third, fx equal to x squared in the interval -1, in the interval -1 to 2. In this interval, okay, in this interval, it's a closed interval. So here actually here is -1, here is 1, okay. So the graph actually is like this. Here is 2, so here this point actually is 4. Okay, so this is the graph. This is the graph. So now for this graph, okay, for this graph, for this function, the minimum actually is here. Yeah?
Yes.
Is here. The maximum is what? Is here, yeah?
Yes.
Is here. So for this function, okay, so for this function fx equal to x squared in this interval in -1 to 2 in this interval, okay? This function it has an absolute maximum. It has an absolute maximum at 2 this point, okay? And it has an absolute minimum, okay? Minimum at the 0, yeah? At 0. So here we can see 2 actually is the endpoints, yeah? 2 actually is the endpoints of the interval, yeah? And the 0 actually is the critical points of the function, yeah?
Yes.
So here means that the absolute maximum is taken at the endpoints. And the absolute minimum, okay? Absolute minimum is taken at what? Taken at the critical point. Critical point. So now, okay, for these three functions, they have a same factor, okay? The same factor is the function is continuous. A continuous function on a closed interval. A continuous function, okay? So here for this three is continuous function on a closed interval, okay? On a closed interval. So we can see for these three, okay, they have absolute maximum and absolute minimum. And the maximum and minimum are taken at the endpoints or the critical points, okay? Or the critical points. So here we have a conclusion. We have a conclusion that if a function is continuous on a closed interval, then the function has an absolute maximum and has an absolute minimum, okay? And the maximum and the minimum are taken at the endpoints or at the critical points, okay? At the critical points. So this is the first conclusion. Now let's see page 235. 235. Now let's see page 235. The result 4.5.4.2, okay? The external view is cylinder. If a function f is continuous on an infinite closed interval, then f has both absolute maximum and absolute minimum on AP, okay, on AP. So here, this is the conclusion, okay? So here is the conclusion. Here, now, the condition is a continuous function on a closed interval. The conclusion is this function has absolute minimum and has absolute maximum. Okay. So here now, from this three, okay, we also know that the maximum and the minimum are taken at the endpoints and the critical points. So now we have a question. If I give you a function, a continuous function on a closed interval, how to find the absolute minimum and maximum? So if I give you a function, a continuous function on a closed interval, so how to find the absolute minimum and absolute maximum? So now we know that the maximum and minimum are taken at the endpoints or the critical points. Yeah. So it's easy. So first you need to find the critical points. Find the critical points and compute the function value at the critical points, and compute the function value at the endpoints. And then from this value, you take a largest one. That one is the absolute maximum. And at that value, you take a minimum. Yeah. The minimum is the absolute minimum. Okay. So from here, now we can see this conclusion. Okay. Now here. So now this is the first conclusion. Okay. If a function f is continuous on a finite closed interval AB. On a continuous function on a closed interval AB, then f has both absolute maximum and absolute minimum on AB. Okay, on AB. So here means that give you a continuous function on a closed interval. This function must have absolute maximum and absolute minimum. Okay, so this is the first conclusion. Now the second here for this one, okay, this one is to how to find a procedure for finding the absolute extrema of a continuous function on a finite closed interval. Okay, on finite closed interval. So the first step is find the critical points of f in this interval. Okay. The second is evaluate f at all critical points and at the end points. Okay, at the end points A and B. So the third step is the largest of the value in step 1 is the absolute maximum value of f, and the smallest value is the absolute minimum. Okay, so here these three steps tell you how to find the maximum and the minimum of a continuous function on a closed interval. So three steps. The first step is find the critical points. The second is evaluate the function value at the critical points and the end points. So among these values, you take the largest one. The largest one is the absolute maximum. Yeah. You take the smallest one. The smallest one is the absolute minimum. Yeah. So here this is the procedure. Okay, so we have this procedure. We give an example.
Devam et fotoğrafı yazmadı. Oraya da bir versin. Bağlı zararsa ya. Hari kita lagi nasıl? Mata muda. Okey. Wow, sekali lagi.
So now, okay, now let's see. The first example is for f. F is 2 times x cubed minus 15x squared plus 36x in the interval from 1 to 5, okay? The second is gx. Gx equal to 6x to the power 4 by 3 minus 3 times x the cube root in the interval minus 1 to 1, okay? Minus 1 to 1. So here, now, we need to find the absolute minimum and absolute maximum, okay? In the interval, okay? So the first step, you need to do what? Find the critical points, yeah? Find the critical points. So here, for the first one, we need to find the critical points, so we need to find the derivative. So f prime x equal to what? Here, 6x squared, yeah? Minus 13x, yeah? And plus 36, yeah? 36. So here, actually we can take out 6, yeah? We can take out 6. So 6x squared minus 5x and plus 6. So here for this one, actually we have factorization. Here equal to what? 6x minus 2 times x minus 3, yeah? So now we let it equal to 0. So we let it equal to 0. So we can find that the critical point is what? So the critical points actually is x1 equal to 2, yeah? The critical point is 2 and 3, yeah? 2 and 3. So the end point is what? The end point is 1 and 5, yeah? So the end points is 1 and 5. So from here, now, okay, here we find the critical points and the end points. So the second step is what? To evaluate the function at this point, yeah? So now the first step, we need to find f2 equal to what? f2 actually equal to 2 times 2 cubed, yeah? Minus 15 times 2 squared, yeah? Plus 36 times 2, yeah? So here equal to what? So here is 2 times 2 cubed. 2 cubed is 8. 2 times 8, so it's 16. Yeah, minus 15 times 4, so 16. plus here is 72, yeah? So the result actually is what?
72 plus
28, yeah? 28. Yeah, 28. So the second here, now we need to find F3 equal to what? F3 is 2 times 3 cubed, yeah? Minus 15 times what? 15 times 3 squared, yeah? 3 squared. Plus 16 times 6. 36 times 3, yes? So here equal to what? So here equal to here is 3 cubed, actually is 27, yeah? 2 times 27, so here is 54, yeah? 54 minus here is 15 times, here is 3 square is 9. 9 times 15, 15.
135.
135, yeah? And the plus here is what? 108. So it is equal to what? Here is
162 minus 27.
27, yeah?
27.
27. So here, this is evaluated at the critical points, and now we need to evaluate at the endpoints. So F1 equal to what? So F1 equal to 2 times 1 cube minus 15 times 1 square plus 36 times 1, yeah? So here is 2 minus 15 plus 36. So it is equal to what? 23, yeah? 23. And F5 equal to what? F5 actually is 2 times 5 cube, yeah? 5 cube minus 15 times 5 square and plus 36 times 8, 5. So here is what? 5 cube actually is what? 100, 5 times 5 times 5, so 125 times 2. So here is 215 minus here is what? Here is 15. Oh, so actually here. Actually, I think that here this part we can recompute it easy, okay? So here, now, we take out this one, okay? This one actually is 2 times 5 cube. Minus here 15, okay? 15, we write it as 3 times 5.
150.
Yeah, and times 5 squared. Yeah, so here is a,
That's
So-
150.
yeah, so here is 2 minus 3 times 5 cube. Yeah, 5 cube. So here actually is minus 1. So here is minus 125 plus here is 118. So the result actually is 15.5. 15.5. Okay.
Yes.
So and this among these 4 wheel, okay, take the largest one. This is the largest one, yeah?
Yeah.
So here is the absolute. So here is the absolute maximum. And take the smallest one. The smallest one is here. So here is the absolute minimum, yeah? Absolute minimum. So here, this is the answer, okay? This is the answer. So here means that the first step, you find the critical points. The second step, okay? You need to you need to evaluate the function value at the critical points and the endpoints. So the third step is take a largest one and take the smallest one. Okay. So here now for the second one here. For the second one now you do access here for this one. Do it yourself. Okay. Here now number 2.
Number 2.
Here number 2.
Okay, I'll show
Number 2. Do it yourself. Okay.
Big ihtimalle böyle yapamıyor. Yapamıyor bro.
Okay, this is equal to 4/3 into 6 x 4/3 minus 1 minus 3 into 1/3
Nasıl yapıyorsun?
Here's x to the power 4 by 3. Here's x to the power 1 by 3. So here I think that you should write it clearly. And I think that you should say here is times. Here is another times. By your pen. So here it is x 1 by 3 divided by x times x minus 2 by 3 power.
facility common there.
So now, when you consider advanced one, the endpoint here. So now, here the endpoint here is right, the right point here. So here, what's the critical points? Critical point. You just compute the endpoints. Okay. So what about the critical points? So here equal to 0, x equal to. No, here is not 1. Here is minus. Okay, so here actually here is 0. X minus 2 by 3 actually is 1 by x 2 by 3.
Maybe like this.
Now, okay, now let's see it. Now let's see it. So gx equal to here. So g prime equal to what? G prime actually equal to 6 times 4 by 3 x. Now 4 by 3 minus 1 part, yeah? And then minus 3 times 1 by 3 x. 1 by 3 minus 1, yeah? So here equal to what? Here actually is 6 times. So here is 8. 8x times 1 by 3 minus here is 1. So here is x minus 2 by 3, yeah? So for this one, okay? For this one, now you need let it equal to 0, yeah? Let it equal to 0. So actually actually you can write it like this, okay? So x 1 by 3, you can write it in what? Here equal to x 1 minus 2 by 3, yeah? 1 by 3 equal to 1 minus 2 by 3, yeah? So here actually this part you can write it in 8x to the 1's power, x to the minus 2 by 3 power, yeah? And the minus x to here, yeah? So you can take out this part, yeah? Take out this part. So here equal to x minus 2 by 3 power, here is 8x minus 1, yeah? Minus 1. So you can write it in this form. 8x minus 1 divided x 2 by 3 power. Yeah? So you let it equal to 0. So you can see x equal to what? 1 by 8. Yeah? So this is the first critical point. Yeah? The first critical point. The second critical point is what? You can see g prime is undefined at 0. Yeah? Undefined 0. So 0 is also a critical point. 0 is also a critical point. So here, now we have the critical points. So the critical point is 1 by 8 and 0. So you need to find, and the end point. The end point is minus 1 and 1. So you need to find the value at this 4 point. At this 4 point. So here now we can see G0 equal to what? G0. Actually, 0, G0 is 0, yeah?
Yes.
G0 is 0. And G1 by 8. G1 by 8 equal to what? G1 by 8 actually is 6 times 1 by 8. Yeah? And minus 3, 1 by 8. Yeah? So here 1 by 8. 1 by 8, we can rewrite it. 1 by 8 actually is what? Actually is 1 by 8. Actually is 1/2 cube. Yeah. 1/2 cube times 4 by 8, 4 by 3. And minus 3 times here is what? Here is 1/2 cube and cube root. Yeah. So the result actually is what? Is 6 times 1/2 to the power 4. To the power 4. 1/2 to the power 4 minus here is 3 times 1/2. Yeah. So here equal to what? So here equal to here actually is 1/2 to the 4th power actually is 16. 1 by 16. So 6 minus 2 by 3. So here is about actually is 8 by 3. Oh, 3 by 8. 3 by 8 minus 3 by 2. So this result actually is what? It's 8, 3 minus 9. Yeah? Oh, no. Here is not 9. Here is 11 over 12. Yeah? So the result actually is minus 9 by 8. Yeah, so the result minus 9 by 8. Okay? And now, so this is the function value at the critical points. And at the end point, g minus 1 equal to what? G minus 1. So here minus 1. Here is 6 times minus 1 to the 4 by 3 power minus 3 times minus 1 cube root. So it is equal to what? Actually here is minus 1 to the 4 by 3 power actually is what? Is minus 1 to the 4th power and the cube root. Yeah? Minus 1 to the 4th power is what? Is 1. 1 to the cube root is 1. So here this one is 1. 6 times 1, so here is 6. Minus here this is what? Minus 1 cube root. Minus 1, yeah? So here is minus 1, 3 times minus 1, minus 3, minus 3, so plus 3. So it's 9. Yeah? And G1 equal to what? G1 here, G1. So 6 times 1, 4 by 3 power minus 3 times 1 cube root. So actually here this is 1, this is 1. So 6 minus 3, so it's 3. So here we can see 0 minus 9 by 8. 9 and 3. So the biggest one is 9, yeah? So the largest one is 9. The smallest is what? The smallest is this, yeah? So here, this is the absolute maximum. This is the absolute minimum, okay? So, I have a break. I have a test of 10 minutes, okay? And minimum must takes at the critical points or at the endpoints. Okay. So now let's see the second case. Okay. When the interval is an open interval. Okay. When the open interval. So here now we see when I equal to the open interval. Okay. Open interval. So now for this case, we give. For this case, okay, we give 4 examples. The first example is y equal to tangent x. For this function, okay, for this function in minus 1/2 pi to 1/2 pi in this interval, okay, in this interval. Now, for y equal to tangent x, for this function in this interval, okay, we plot the graph. The graph actually is like this. Here is x, here is y, Here is minus 1/2 pi. Here is 1/2 pi. So the graph actually is like this. Now we can see, okay, for this graph, when x approaches 1/2 pi from left, the graph will go to infinity, go to plus infinity, okay? And when x approaches minus infinity from right, the graph will go to minus infinity, okay? Minus infinity. So for this function, we have this limit where x approaches minus 1/2 pi from left, from minus 1/2 pi from left, okay, from right. Fx, this limit is minus infinity, okay, minus infinity. And limit x approaches 1/2 pi from left. Fx approaches what? Plus infinity. So for this function, we can see, do we have the absolute minimum or absolute maximum? Actually, for this function, okay, for this function in this interval, we do not have absolute minimum and absolute maximum. Yeah. So for this function, okay, for this case, we do not have no absolute extrema, okay, extrema, no absolute extrema, okay, for this case. So this is the case, the first example. For the second example, now we consider y equal to minus tangent x. Also in this interval, okay? Also in this interval, minus 1/2 pi to 1/2 pi, okay, to 1/2 pi. For this function, okay, for this function in this interval. Now, here is x, here is y. So we plot the graph. Actually is minus tangent x. So the graph actually is like this, okay? Is like this. So here is the same, okay? When x approaches minus infinity or minus 1/2 pi from right, the graph will go to plus infinity. And when x approaches plus 1/2 pi from left, the graph will go to minus infinity, okay? So here for this function, we have limit fx when x approaches minus 1/2 pi from right. This is equal to what? This is equal to plus infinity. And limit x approaches 1/2 pi from left. Fx approaches minus infinity, okay, minus infinity. So for this function, okay, actually we do not have for this function, okay, we do not have absolute extrema, okay, we do not have absolute extrema. So this is the second case. Here means what? When the x approaches left, the left endpoints, so fx approaches minus infinity. Means one side plus infinity, one side minus infinity, okay? One side plus infinity, one side minus infinity. In this case, we do not have absolute extrema, okay? We do not have absolute extrema, okay? So now for the second example, now we consider the example. Y equal to 1 by x x minus 1 times 2 minus x. For this function, okay, x minus 1 times 2 minus x. For this function in this interval 1 to 2, okay, 1 to 2. For this function, okay, for this function here, now let's see limit when x approaches 1 from right. When x approaches 1 from left, fx, this function approaches what? X minus 1 times 2 minus x. So this function approaches what? Now let's see, x approaches 1 from right. This part, x minus 1 approaches what? 0 from left or right? X approaches 1 from right. So this one, x minus 1 approaches 0 from left or from right?
Right.
Right, yeah?
Right.
So here approaches 0, 0 from right.
Right.
0 approaches what?
2 minus 1.
X approaches 1, 2 minus x approaches what?
1.
1. So 1, 0 times 1 is 0, yeah?
Yeah.
1 by 0. 0 here is positive.
Positive infinity.
So 1 by 0
Positive infinity.
is what? So here is plus infinity, yeah?
Yes.
Plus infinity. So now, this limit is plus infinity. Now we can see another. X approaches 2 from left. 1 by x minus 1 times 2 minus x. Now for this function, okay? For this function. Now let's see here. When x approaches 2, x minus 1 approaches what?
1.
1. Yeah? 2 minus x approaches what? 0.
0.
0 from left or from right?
Left.
From left.
Left.
X approaches 2 from left, means x is less than 2, yeah?
Yeah.
So 2 minus x less than, greater than 0 or less than 0? X less than 2, so x
Less than 0.
less than 0.
Great.
X less than 2, 2 minus x less than 0 or greater than 0? Here x is less than 0, yeah? So 2 minus x, of course, is greater than 0, yeah? So here is 0, here is x approaches 2 from left, 2 minus x approaches 0 from right, yeah? So 1 times 0 from right, 1 by 1 times 0 from right. So here is what? This infinity is what? The limit. It's also plus infinity, yeah?
Yes.
So here is, so the graph of this function actually like this, okay? So here is 1, here is 2, here is 1, here is 2. So when x approaches 1 from right, it is go to plus infinity. So here is like this, okay? When x approaches 1, here is 2. When x approaches 1, it go to plus infinity. When x approaches 2, it go to plus infinity. So actually for this function, we have what? For this function, actually we have what? We have absolute what? Absolute minimum, yeah?
Yeah.
So this is this function, okay? Now if we take a negative sign here, so for this function y equal to minus 1 by x minus 1 times 2 minus x. It's also in this interval 1 to 2, okay? It's also in this interval, this function, okay? So first now we compute it. Limit x approaches 1 from right, minus 1 by x minus 1 times 2 minus x. So this limit is what? Actually, this limit and this limit, just a negative sign, yeah? So here is negative plus infinity. So here is what? Minus infinity, yeah? Yeah. and the limit x approaches 2 from left. So minus 1 by x minus 1 times 2 minus x. So here actually is also minus infinity. Yeah? Minus infinity. So here we can see, we can plot the graph. Here is 1, here is 2. So when x approaches 1 from right, it go to minus infinity, and here is also minus infinity. So actually the graph is actually 96. Okay, here is when x approaches 1 from right, it go to minus infinity. From 2 go to minus infinity. So here we can see this function will have a what?
Absolute maximum.
Have an absolute maximum. So here now, this is the case for when the interval is an open interval, okay? So open interval. So now let's turn to the PPT, okay? Now let's turn to PPT. Now let's see the four. We have these 4 cases. Okay, the first case is when x approaches minus infinity. When x approaches minus infinity, fx approaches. I'm sorry. Not this one. Okay. Yeah, this one. Okay. So I make a mistake here. It's an open interval. Okay, an open interval. When x approaches a from right, fx approaches plus infinity, and x approaches b from left, fx approaches plus infinity. So here left plus infinity, right plus infinity. So we have an absolute minimum, but no absolute maximum. Okay. For this case, we just have absolute minimum, okay? Do not have absolute maximum, okay? This is the first case. The left go to plus infinity, the right go to plus infinity. So we just have the absolute minimum, okay? So the second here, now we can see the left go to minus infinity, the right also go to minus infinity. So the left go to minus infinity, the right go to minus infinity. So we just have what? We just have absolute maximum, but no absolute minimum. Okay, but no absolute minimum. So here this is the third. Okay, so the third way, the left go to minus infinity, the right go to plus infinity. The left go to minus infinity, the right go to plus infinity. So for this function, okay, we do not have absolute maximum and absolute minimum, okay. And now for the case 4, okay, for this case, the left go to plus infinity, the right go to minus infinity, the left go to plus infinity, the right go to minus infinity, okay. So for this function, do not have absolute maximum and or do not have absolute minimum, okay? So here for this case, so if I give you a function on an open interval, okay, on an open interval, so you need to see when x approaches the left points, the left endpoint from right, the fx go to what? And when x approaches the right endpoints from left, the fx go to what? Okay, so this 4 cases. So I think that it's easy to imagine. Okay, so if the left go to plus infinity, the right go to plus infinity, so of course we have absolute minimum. Yeah, do not have absolute maximum. If the left go to the minus infinity, right go to minus infinity, yeah. So for this case, we do have an absolute maximum. Yes. Do not have minimum. Yeah. And if the left go to minus infinity, the right go to plus infinity, or the left go to plus infinity, the right go to minus infinity, yeah. For these two cases, we do not have absolute minimum or absolute maximum. Okay. So I think that you just keep in mind. You need to see what? You need to see the left limit and the right limit. Okay. You see these two limits, then you can have the conclusion. Okay. Have the conclusion. So here, so of course, okay. Of course, for the minimum or maximum, this one is also the critical points. Okay. The critical points. So now we I give you an example. So now I give you an example. So you can see here, first x approaches 2 from left, x minus 1 approaches 1.
Indoors.
X approaches 2 from left, x minus 1 approaches 1, yeah? And x approaches 2 from left, x 2 minus x approaches what? 0, yeah? So you can see here, x approaches 2 from left means x less than 2. Less than 2, so 2 minus x is positive or negative. X less than 2, for example, x equal to 1.5, so 2 minus 1.5, so here. Now let's see the example. Determine whether fx equal to 1 by x squared minus x. 1 by x squared minus x has any absolute extrema on the interval 0 to 1. Okay, 0 to 1. So for this function, so here is a function on an open interval. Okay. So now we need to see the left limit and the right limit. Okay. The left limit and the right limit. So here now we need to see limit x approaches 0 from right. Yeah? X approaches 0 from right. Yeah? 0 from right. So x approaches 0 from right. Fx approaches what? Yeah? So here equal to what? So here equal to limit x approaches 0 from right. Here is 1 by x. Here we can take 1x. So here is x times x minus 1. Yeah? So here we can see x approaches 0 from right. This one approaches what? This is 0 from right. Yeah? Here this is what? X minus 1. When x approaches 0, x minus 1 approaches what? Minus 1. So 0 times minus 1.
0.
0, yeah. So 1 by 0.
Plus infinity.
Infinity, yeah. So here is plus infinity or minus infinity.
Plus.
So not here. So here is a positive times a negative. So of course here is a negative, yeah. 1 by negative 0. So here is a minus infinity. Minus infinity, yeah. So this is the first one. Now the second here, x approaches 0 or no 1. X approaches 1 from left. Yeah? From left. From left. Okay? From left fx. So it is equal to limit x approaches 1 from left. 1 by x times x minus 1. Yeah? So x approaches 1 from left. This part approaches 1. Yeah? X minus 1 approaches what? 0 from left or from right? X approaches 1 from left. So x minus 1 approaches 0, yeah? 0 from left or right?
Right.
Left, yeah? Because x is less than 1, yeah? X less than 1, so x minus 1 actually is less than 0, yeah? Less than 0, so from left, yeah? So 1 times 0 from left. 1 by here, so here is minus infinity or plus infinity? Minus infinity, yeah?
Yes.
So here means the left the minus infinity, the right minus infinity. So the function have a what? Have a maximum, yeah? So absolute maximum, yeah? So now we know, so the maximum takes at what? The critical points, yeah? So now we need to find the critical points. The critical points at this interval. So we need to find for this function, okay? We need to find the derivative. So the derivative, f derivative equal to what? Equal to, here is fx divided by gx. So it is gx square x square fx prime, f prime times g. F prime is 0 times g minus f times g prime. This prime, yeah? This prime is 2x minus 1, yeah? Minus 1. So now you let it equal to 0. You let it equal to 0. So now we can see here.
Please just repeat there.
So actually here, this function is fx divided by gx. This prime, yeah? This prime equal to what? Equal to gx square f prime times g minus fx times g prime, yeah? Yeah? So here f is what? Here f is 1. So 1 prime is here, this part is 0. So 1 times g prime, yeah? We use this formula, okay? The formula. So you let it equal to 0. So we can see x equal to 1/2, yeah? So x equal to 1/2. And 1/2 is a critical point, yeah? The second is this denominator cannot equal to 0, yeah?
Yes.
So f prime, okay? F prime is undefined, okay? Is undefined at what? At x squared minus x equal to 0. X squared minus x equal to 0. Here means x times x minus 1 equal to 0. So x equal to 0 or x equal to 1, yeah? At 0 and 1, yeah? So the critical point, we have 3 critical points, okay? The first is 1/2, the second is 0, the third is 1. But the third critical points, just this critical point are in this interval, okay? Just this critical point at this interval. This 0 does not belong to this interval. 1 does not belong to this interval. Because 0 here is open, okay? Open interval. So here means that here means the absolute maximum takes at this point. So the absolute maximum takes or occurs at x equal to 1/2. Okay, equal to 1/2.
Now, what is it?
Now, so this is this part, okay? Now we have the last part. The last part, so now let's see if the interval is minus infinity to plus infinity, okay? Minus infinity to plus infinity, so actually it's the same, okay? It's the same. So now if I equal to minus infinity to plus infinity, okay? For this case, so I think that the class is you are late, okay? You are late. So when the interval is from minus infinity to plus infinity, okay? In this case, now actually we give 4 examples. Okay? 4 examples. The first example is fx equal to x square for this interval, for this function. Okay. Now it's easy to see limit x approaches plus infinity, x square approaches what? X approaches plus infinity, x square approaches what? Plus infinity, yeah? And limit x approaches minus infinity, x square approaches what?
Plus infinity.
Also plus infinity, yeah? So the left go to plus infinity, the right go to plus infinity, so we have what? So actually the graph actually is like this. Yeah, so minimum, yeah, minimum. So for this function, for this case, we have absolute minimum, okay? Absolute minimum. No absolute maximum, okay? No absolute maximum. This is the first case, okay? The first case. The second case is now we can see this function fx equal to minus x squared for this function, okay? For this function, it's the same. Now, x approaches plus infinity, minus x squared approaches what? Minus infinity, yeah? Minus infinity. And the limit x approaches minus infinity, minus x squared approaches what? Minus infinity, yeah? So this function, left go to minus infinity, right go to minus infinity, so this function have what? So, actually it's like this, okay? Like this. So here, this function has the absolute maximum, but no absolute minimum, okay? So this is the second, okay? The second case. Now let's see the third case. Now let's see the third case. The third case is fx equal to x cubed, okay? For this function, okay, now the same. Now let's see the limit x approaches plus infinity x cubed equal to what? Plus infinity x cubed approaches what? Plus infinity, yeah? And the limit x approaches minus infinity x cubed approaches what? minus infinity. So here means that the right go to plus infinity, the right go to minus infinity. So here,
No maximum, no absolute.
so here is no absolute minimum,
No maximum.
no absolute maximum. Okay. So this function actually you can plot the graph. The graph actually is like this. Okay, like this. So this is the first, or this is the third case. Okay. Now for this case, fx equal to minus q, x cube. So for this function actually it's the same. Limit x approaches plus infinity minus x cube approaches what? Minus infinity, yeah? And the limit x approaches minus infinity minus x cube approaches what? Plus infinity, yeah? So here, the left go to plus infinity, the right go to minus infinity. So here, of course, this function no absolute minimum or no absolute maximum, yeah? So here the graph actually is like this. It's like this, okay? So here this is the four case, okay? The four case. So we have evolution, now see the PPT, okay?
Yes, এমনি করে তো মার করতে পারতাম
Here?
নো
Now,
নো নো নো
now let's see here. When x approaches minus infinity, fx approaches plus infinity. So means the left go to plus infinity, the right also go to plus infinity. So in this case, f has an absolute minimum, okay, but no absolute maximum, okay. And the minimum actually is the critical points, okay, critical points. Now for the second case, for the left go to minus infinity, for the right go to minus infinity. So in this case, we have an absolute maximum. The maximum actually is the same, okay? It's the same with the critical points. Critical points. So here, for the third case, the left go to minus infinity, the right go to plus infinity. So this case, we do not have absolute maximum and absolute minimum, okay? This case is the same. The left go to plus infinity, the right go to minus infinity. So we do not have absolute maximum or absolute minimum, okay? So this is this case, okay? This four case. So here means what? If I give you a function and then now need you to see the function to find the absolute minimum or maximum on minus infinity to plus infinity, okay? So here means that you need to see the limit, okay? The two limit. So here, so here this is the result. Okay. So now we give an example and then end the class. Okay. We give an example and end the class. So I know you are tired. Actually, I'm tired also. Okay. Yes.
next day the class
We have exam from 7 p.m.
and this is নিশা করে দিলাম না বুঝতে বুঝতে
So now, okay. Now let's see this function. This function, okay, x squared minus x minus 2. For this function, okay, now we need to find the absolute extrema, okay, on this interval, So here now, we need to see what? We need to see the limit, yeah? So now first we need to see limit x approaches minus infinity, x approaches minus infinity fx. This limit is what? Now equal to what? Limit x approaches minus infinity, here is x squared minus x minus 2, yeah? So here we can see this part. Actually this is a polynomial, okay? So for a polynomial where x approaches plus infinity or minus infinity, we just need to see what? We just need to see the high degree, okay? It's a high degree part, okay? The high degree part. So this limit actually equal to limit x approaches minus infinity x squared. They are the same, okay?
Yes.
Because here is a polynomial where x approaches plus infinity or minus infinity. We just need to see the high degree term, okay? The high degree term. So the high degree term is x squared. So this limit is what? Plus infinity, yeah? Yes. And the second, where x approaches plus infinity fx equal to limit x approaches plus infinity x squared minus x minus 2, okay? So this is also, we just need to see the highest degree term, okay? So it is equal to limit x approaches plus infinity x squared is equal to what? Plus infinity. So the left plus infinity, the right plus infinity, so we have what? So we have absolute minimum, yeah? So the minimum takes at what? Critical points, yeah? So we need to find the critical point is what? So we need to find the f prime equal to what? 2x minus 1, yeah? 2x minus 1, you add it equal to 0. So x equal to what? X equal to half. So the absolute minimum occurs what? Occurs at x equal to half. Yeah? So it's easy. So first you need to see the left and the right, okay? And to determine the function have or do not have absolute minimum or maximum. Okay? So here so this is the end of the class. So thank you.
Thank you.
तो अब किसको थाम से बनाने का ও যত বন্ধ করি